Hello everyone. In this video we are going to talk about PIR motion sensors. These are passive infrared. So first of all, they are passive. They don't send anything. They just receive the motion, they receive the infrared or heat changes, and they are passive, which is really good when you don't want to get detected, right? You just want to detect, not be detected, because they are not sending anything out. And the good thing is they are infrared, sensitive to heat, so you can use them at nights too and not just for days. And so the one that I have here, you see that if I go anywhere close to it, to a distance of 10 to 20 feet, it has the detection range and it can detect it and then sends this voltage to LED to turn on, right? So instead of that LED, it could be a buzzer or anything else. It could be something that is sent to my camera, right? And it's very sensitive, right? So look here. I go, even I don't need to put my hand all the way close to it, it is going to turn on. And if it doesn't detect any changes after a little bit time, it goes off. But it's extremely sensitive, right? You see here? So as soon as I move anything close to it, look here, it turns on, and again, you see, it goes off. So it's very good. Now, if I want to show you what code to use to run this and a little bit more information about it. So as I said, first thing is, this is a passive sensor, okay? Passive infrared or PIR sensor. Now, it has 3 major pins, and these pins are ground, the high voltage, and the out signal, okay? And in my case, that's the same thing. So the ground, of course, is connected to the ground. So this yellow one, which is the ground, it is connected to the ground. This middle pin, the high voltage, is attached to the 5 volts, and then the out here is attached, as you can see, to pin 5 of the Arduino. So it can detect basically the readings from it. And then from pin 9 of the Arduino, I'm sending the voltage to the positive leg of the LED, and the negative leg with a 1K resistor is connected to what? To the ground. You can use a 220 or 330, right, to reduce further the intensity of the LED and use a bigger pull-down resistor. So the detection range for this sensor is up to 15 feet if you use it on short setting. If you go on long setting, it can go up to 30 feet. The current for it is 12 milliamps if you use 3 volt supply, and up to 23 milliamps if you use 5 volt supply. So you can directly basically go with the Arduino without any resistor or anything, because 5 volts and 23 mils is what you can get out of a pin, or send to a pin in this case, and it is totally fine. And whenever it detects an object, it sends a high signal. So it is low, but as soon as it detects any motion, it goes to high signal here. Now, one very important thing when you're working with a PIR sensor, as soon as you connect it, you should not immediately try to test it. You have to give it some time to calibrate. So it calibrates, hey, if there is no motion, what kind of heat do I get from the environment? So if something comes into the view, then how much increase do I expect to get? And then based on that, it gives you a high or low signal. So the first typically 10 to 60 seconds, you do not do any reading, you just let it calibrate. And you see in my code, if you go to the code, which actually I did not really entirely write, I got it from a website that I show you. But initially, basically, you see that some time is given to it, right? So you see, initially, I'm giving it some time to calibrate, so it doesn't do anything. When it's done with calibrating, then it says, hey, the sensor is active, and now it is done all under setup. Now, in your loop, you're going to do digital read of the PIR pin, which in my case, as I said, that's pin number 5. And I read that, and then I'll show you how to go with the logic of this, okay, and turn the LED on or off. but basically you have to give it an initial calibration time. Okay, and during this time it wants to measure the baseline. It wants to measure if there is no motion, what should I get? So you have to minimize the movements during this time around the sensor. When the sensor is calibrating, don't put anything in front of it, otherwise it shifts up the baseline. So that is very essential when you are dealing with this kind of PIR sensor. So that is how the sensor looks like. As I said, this is a circuit for it, and I'm going to show you how the code is working. Now I demoed it for you, right? So as soon as I move my hand or anything on the way, it is going to turn on, and then after that it is going to turn off. And it also shows you that the motion was detected and ended at what time. So it also shows the time for it. But this is the initial part that I said. It says calibrating sensor done, activate sensor active, and then after that you are going to get the readings. So let me explain this code briefly for you. So this is for serial communication to show this stuff. You see the PIR pin is input, the LED pin is output, and first I'm going to set a low to the PIR pin. Assume that initially you start with no motion. Now what? Now first I do my calibration. So this is all the calibration part. Wait a little bit, right? So you see I'm doing a bunch of delays, and it goes all the way to calibration time, which is 30 each loop counter from 1 to 30, I wait 1 second. So this thing takes about 30 seconds to calibrate, and then another 50 milliseconds here to say sensor is active. So here, if I want to say, that is 30 seconds that you have for calibration. As I said, anywhere between 10 to 60. If you want, change that number to 60 to make it 60 seconds. Good. Now what would you do in the loop? If you read the pin and the pin is high, that means there is some motion. If there is a motion, go ahead and write a high to the LED pin. So turn the LED on. Then what? If lock low, now lock low, here is a flag. As you can see, lock low is a flag. You initially started with true. Okay, it's a Boolean variable that you started with true. If that variable is true, and in the beginning it is true, then what happens? Then you're gonna set it to false. You write these 3 lines, then say motion detected, divide the millis, the current time, by 1000, type seconds, 50, and then take the take low time to true. And then what? So if I just want to explain this part, the first if, what are you doing here? So the fact that you're adding this extra if here under the part that you're receiving a high means a motion is detected, and then you have to turn the LED on. Why is this written? Here you make sure that you are not writing all these parts that the motion is detected at so much. You are not writing it a ton of times during the case that you have basically your hand in front of the sensor. So look, when I move my hand in front of the sensor, you see it only writes it once. And then when I move my hand away, it only writes again that the motion ended 1 time. So you see, that's all that you do 1 time per receiving the high signal and receiving the low signal. Because it reads those high and low signals very fast. And if you don't put this kind of logic here, right, and first you start with true, so it does it, and then immediately, as soon as that's the case, you turn it to false, write this, so next time it wants to come back, it knows this is false, so this part will not take place again. Okay? And of course, you only do this during a high signal, and when you go to the low signal now, you turn the LED off, and again here, you see I have this variable that, again, if it's true and then you turn it to false, again, this message that motion ended only happens once. Now here, in order for the motion to go low and it writes this, you need to basically wait a little bit of time, called pause. How much is this pause? It's 2 seconds. Okay, so you have to wait for 2 seconds, right, before you can say that, yeah, this motion is off now, there is no motion. So you see you're reading the current time millis subtracted from the millis in the beginning, so that is the elapsed time. If it's bigger than 2 seconds and the lock low is not of that, what does that mean? It means lock low should be false, so not of that is true. So you are doing a transition here. It was on, now you are going off. You're doing a transition. Sufficient time, 2 seconds have passed. Go ahead and write that in seconds, right? Go ahead and write it in seconds. Here you're dividing by 1000 and write it in seconds that how much time have passed since the motion is ended. Okay, so this take low time and this low lock are used to only write those messages once, and you have to wait for so much time here. If you want, you can change that. If you want, you can change the calibration time. And here I have added these 2 lines of explanation for you for these logical variables or Boolean variables. And I assume everything else is clear. Now, just for the sake of full disclosure, I would say, here are the 2 websites that I used. So the second one is where I got the code. And this first one is where I got this picture or this circuit diagram. I modified things a little bit, but not too much, so the credit goes to these people. And my goal is just education here and explanation of a PIR sensor and show you that how you can detect a motion and turn on LED or turn on a buzzer or anything else that you want. Before I finish this video, I just remembered there was one thing that I wanted to discuss, and that was this setting. I said that you can change the setting so you can detect a bigger range or a smaller range. What is that? So let's talk about it. First of all, when these IR sensors, they look in front of them, the angle that they see, if you look at them from a top, right? So if this is their top view, the field of view for them, most of the time, this angle from here to here, this is about 110 degrees. That is their field of view, but this distance that they see can go anywhere from 15 to 30 feet, okay, which is basically somewhere like 5 to 10 meters or so, okay? And some say up to 7 meters, but they can go a little bit more. So how do you do that? Well, here, if you look at one, and I'll show you, there are these 2 basically screws here that if you tighten them or loosen them, you can change what? You can change your sensitivity on one of them. The other one is the delay time. What is the delay time? What is the sensitivity? Sensitivity is basically this distance. Okay, that is this distance, but what is the delay? So this delay is how much time the signal will stay high after an object motion is detected, and after that it goes down to what? To low. So how much time the signal stays high after detecting a motion, that is this delay which you can set. Okay? Now, if you look at one, let me show you. So here we are going to go with one of these, and I'll show you a physical one. So this is what I told you, and these are those 2. Let me bring my screwdriver. So these 2 that you see, the right one and the left one, right here. But remember, the view I showed you was like this. So basically in that view, the right one was sensitivity, but if I look at it this way, it's the left one. So it's this guy, that is the sensitivity, this one is the delay. Now in this one, if I go clockwise, if I turn it clockwise, let me show you. So if I go like this and I turn it clockwise, that will reduce the sensitivity to smaller distances. If I go counterclockwise, it detects bigger distances, okay? And we have a similar approach here for the delay, okay? So the delay can also be set to bigger delays or smaller delays, and again you see that as soon as I bring my hand in front of it, it is going to turn on or off. So those two screws in this view, the left one sensitivity, the right one is the delay, and clockwise means decrease and counterclockwise means increase. Those are the settings for the PIR sensor here. So I guess now I have covered the material I wanted to cover for you, including these two settings, the range, and how a simple code works for this PIR. I'm going to let you download this code under video description so you can play with it, you can change some of the settings and learn more from a passive infrared motion sensor. Thank you so much. I'll see you in the next video.